So it's good afternoon and welcome to this afternoon session on enhancing applications with SQL Server data mining. My name is Peter Myers. I'll be your presenter and look forward to sharing with you this topic of data mining that I find is commonly not known exists in SQL Server. Or it exists but wouldn't know where to find it, or even if I could find it, what would I do with it? I'm interested to know here in the room this afternoon, how many of you have already worked with SQL Server data mining before? So as I expected, I see about 4 or 5 hands. So out of this audience, it's probably about 8 or 9% of the group. Okay, what I would hope to achieve in this session then is to inspire you with the potential of what you can achieve with SQL Server data mining. There's a secondary topic, and that is not just the data mining, but how can we use the data mining results and embed them into applications? So there's 2 different audiences in mind here. There's those that are curious to understand and evaluate what SQL Server data mining can do. The second audience would be .NET developers that are looking to take their application to the next level by including data mining results to enhance the application experience. I'm a BI expert. I've been working in this space for, well, over 10, 12 years now. SQL Server MVP in recognition for the community work I do, like speaking at user groups, conferences, and so on. Focus on education and mentoring, and based in Melbourne, Australia. The objectives then, today, assuming no background with data mining, is to begin with the very basics. What is data mining, and what are the processes involved in producing and maintaining a data mining solution? We'll then introduce SQL Server data mining with its capabilities and features, and then we'll introduce its 9 algorithms and the potential use of these algorithms. Finally, I have some 5 demonstrations that will show you different scenarios on how data mining could be used to enhance an application experience, leading from those that are the most simple to some that are more sophisticated. Let's start with what is data mining. So it very much addresses the problem that we've got a lot of data, but we don't know enough about it. There are limitations to the way that the human brain works. And those limitations certainly come to the fore when we have volumes of data and complexity in what our data represents. So data mining as a technology is there to detect patterns. And that could be knowledge itself. The fact that we learn some pattern about our data tells us something that might have been very difficult to obtain by querying the data directly, perhaps by using a pivot table and slicing and dicing. Maybe we could have arrived at the discovery of a pattern, but it could have taken some time and maybe sheer luck to have surfaced some pattern that lives within our data. Now, where you trust these patterns, you can use them in prediction scenarios. If it's happened in the past, it's likely to happen again. And so a very, very common use of data mining is not just to describe data, but to perform predictive analytics. All up, data mining does form a key part of a business intelligence solution. Let's take a look here at the topic of predictive analytics, plotting here against the role of software, the business insights that could be delivered. So down at this level, passive role of software, just presentation of data. This is where your canned reports come in. This isn't data mining. We would have some parameterization on those reports, and perhaps we could detect some interesting patterns, but not likely. Those reports are typically there to answer the continual questions and the repetitive questions you have. Now, when it comes to less repetitive questions, you have the ad hoc reporting. That I have a particular question in mind, it's a one-off, let me go ahead and write the query and present the query result in some report. That provides more interactivity, and certainly as we move up to the data model, be it a cube or a tabular model, slice and dicing with a pivot table, you have more ability and interactivity and flexibility to discover what your data has to tell you. But it's not until this level up here where data mining really fits in, a very proactive approach and delivering deep discovery potentially from your data. Let's look at some scenarios for the use of data mining, of which there are many, and it may be of interest to you to know that, just by browsing a common public web application, there's probably data mining going on in the background. The targeted advertising that is shown to you is typically not random. They can collect information about the newspaper articles you've been reading within the session, and they will use that to drive a dynamic experience to better pitch and target advertising to you. So here's the first example. We want to know who the profitable customers are. Instead of sending that expensive, glossy brochure to every customer, let's see if we can identify with a high degree of confidence those customers that are likely to buy from us. And then we can more wisely spend our marketing and sales budgets by targeting these groups. Understanding customer needs. The classic would be, if you've ever been to Amazon.com, You're looking at a book. What else do you see on that page? Those that bought this also bought these. Association analysis, strongly used. Anticipating customer churn. So when you think of an industry like the telecommunications with mobile phones, it's unlikely you'll encounter someone today that does not own a mobile phone. What it means, however, is that they're dissatisfied with their carrier. They'll keep their phone, but they'll move to another carrier. And that's what we refer to as churn. And if you think about the principle that maintaining and retaining an existing customer is far cheaper than finding a new customer, data mining is used to identify customers that may likely leave your service. It may well explain those phone calls you get from time to time to say, well, we see that your contract's up for renewal. Here's a deal. We'll give you a discount if you renew for the next 12 months. The prediction of anything across a time series. So the examples given here would be sales values, inventory values. If we've got a time series, there's the last 24 monthly inventory levels that we had. There's likely to be some type of pattern in there that could produce a model that would allow us to predict with higher accuracy than the old gut instinct what the future steps within that series could be. Now, at this point, I'd like to make it absolutely clear that data mining is not an exact science. We could never expect that to predict the future currency exchange rate is going to be 100% accurate. But what we'll typically use is data mining to support our intuition and our domain knowledge that we already have. Does it back it up? Where it doesn't, is there something that I'm overlooking? All right, so we don't blindly take data mining results and just accept them, not without great care and testing. Building effective marketing campaigns pretty much ties to the first one, I think. If you can detect the profit that certain customers with their demographic attributes would produce, you could leverage that for more effective marketing campaigns. A huge area for data mining would be the detection of anomalies, whether it's fraud or just unusual things. And again, think about the example you may have come across where your bank or credit card company call you up to say, this transaction's happened on your account, but it seems irregular according to what you typically do. Is it you? All right, I've had these a fair few times. All right, that's data mining working in the background. It understands the patterns of your transactions and it sees something that doesn't quite fit or doesn't fit closely enough. So a variation of this could be during an ETL process to populate your data warehouse, is that you could use this to cleanse or to identify potential dirty data. All right, so out of interest, Integration Services has a data mining component in the data flow that could let you look up the probability of how confident the data mining model is that this would exist, and you could use that downstream in your data mining, or rather your data flow, to maybe split it out into a log table to allow someone to inspect this data because it doesn't look quite right. The fact is there are numerous applications to data mining, and that's the takeaway from this slide. When it comes to producing a data mining process, I have this chart for you here. It starts in the top left corner, and importantly, and really it's no exception to any type of project, but we do want to emphasize that you need to understand the problem that you have and how you're trying to solve it. What's interesting about a data mining project is it's typically very targeted to solve one particular problem. Unlike a general database or even a cube that might be there to solve multiple different problems in a related subject area, a data mining model is typically there to solve one specific need. Having a firm grip and grasp on what your problem is, you can move to the next phase, which is to understand the data that you have. Do I have enough data? Do I have the right amount of data? Do I have the right quality of data? The garbage in, garbage out principle totally applies here, that if you have garbage data, don't expect the data mining results to be any much better. So we spend significant times understanding the data that we have available to us, and then we move into the data preparation phase, which allows us to inspect the volumes of data we have, the quality of data that we have, and also the content type. So we're storing numeric values as continuous values. We're using discretization to group them. For example, age could be discretized from 20 to 25, 25 to 35, and so on. Or as clustering techniques prefer, they like to work with normalized values. So we might have a continuous range of numerics, but we'd like to see ranges between 0 and 1. So we would prepare the data in advance to optimize the type of data mining problem we're solving. Now, there are entire books and huge books written on this topic, and I'll take this opportunity to share with you that data mining is an advanced topic. It typically requires that you have a good understanding of mathematics, in particular statistics, that you understand Error margins. That's a healthy respect we need to have in data mining because nothing's perfect, but we need to understand how confident a model is of predicting values for us. So having said this, in my day at university, it was a master's or PhD level that you would start working in data mining. Today, I think it's a bachelor's level. And the prerequisites are that you have a good statistics background, and then you can move into some data mining theory and application. Now, having said this, I will return to this topic shortly because we don't expect that developers or even SQL Server developers should necessarily have to have such a robust background to exploit and leverage the capabilities of SQL Server data mining. So, data preparation. Significant amount of time is spent here getting the data just in the right shape and format. What that means will depend on the problem you're solving. Hard to explain that to you without a particular problem in mind. Then finally, we can get to the modeling point of view. Now, a model involves the selection of inputs and outputs, an algorithm, and parameters that will control how the algorithm will do its job to detect and store the patterns that it finds. Now, you might think at this point that one model would be sufficient, but the reality is you will create numerous models here, perhaps slightly different variations, maybe a filtered set that we have females versus males. Let's look if we get a different result across gender. What if we use different algorithms that can achieve the same type of task? What if we use different inputs? What if we use different volumes of data? Instead of 1 million cases, what if we just use 500,000? It'll be quicker to process, but will it be as accurate and useful? There are so many variables that you can play with here that we would strongly suggest you will create a series of related models. You will process them all, which will involve them detecting patterns and storing them, and then you'll move into the evaluation phase. And at the evaluation phase, your goal is to identify and to promote into production the model that best does the job. All right, so there are various techniques that we want to test the accuracy, the reliability of how the model performs. We would then deploy that, and then the model becomes a queryable resource upon which you can then write queries. They can be executed real time within application experiences to then expose meaning or prediction back to the application. So there, in a very high level introduction, is the process involved in producing a data mining solution. A word here on data preparation. I already covered this in some detail, but some things that you might like to do would be transform and cleanse the data, isolate and remove abnormal data. Well, actually, it depends. Isolate and flag would be a better way to say it. Here's an example of where you may not want abnormal data. Sometimes things actually happen that are quite weird and extreme. For example, you read about those articles where some 9-year-old got a PhD. It does happen. But if you had university records of students, you'd probably want to remove that because it just does skew the results. It's not commonly what we expect to happen. Now, if we're looking for fraudulent bank transactions, we might choose to oversample what we know is fraudulent to actually make the model focus on it and perhaps build a cluster that it then identifies that this is a fraudulent transaction. So there's different ways you can go here. Remove to reduce the skewing of results, or oversample to make sure that the data mining algorithm picks up that there's an undesirable pattern here that we need to be aware of. We have missing values. We can substitute them. In fact, you can use other data mining techniques to fill in what missing values could be. The discretization of values, again, the example of age. Instead of working with a continuous range, the difference between the purchasing patterns of a 25-year-old and a 26-year-old probably isn't very different. We might put them in that group of 25 to 30. And the normalization, clustering likes normalized ranges of values. Of course, having the required data to begin with is important, and I like to use the example that let's suggest that you're building an e-commerce application. It requires that your customer authenticate, and in order to do this, you establish a profile for them. When they sign up to your application, they give you details like email address and so on. What we would strongly suggest is, even if data mining is not relevant immediately, is that you want to capture and maintain quality information about your customer. Obviously, within legal boundaries, asking questions like age, gender, and so on is a great thing to do today, even if you think it's not relevant to what the application needs, because it could become relevant in the future as you start to mine the data that's being collected by your application. Now, be aware of, and it's sort of a funny example, the Afghanistani accountant example. I used this example recently and I had an evaluation come back and say that I was being racist. No, I'm not being racist. Imagine what happens is that if you are, for the convenience of your user, defaulting to the first item in a drop-down list, What is your nationality? Afghanistan. What is your occupation? Accountant. What do you think is going to happen to the quality of the data that you're collecting that describe your customers? All right, there's an example where you're going to probably have to remove Afghanistani accountants because they're skewing the results. All of a sudden, there will be this overemphasis of the fact that you've got people from this country and with this occupation. So there's an example whereby an appropriate UI experience should be do not default to something. Make them. Select something and don't allow them to move forward with the commitment of that data entry until they've entered a satisfying value. At modeling time, we design the model. As described, that defines inputs, outputs, algorithm, and algorithm parameters. At process time, we take that carefully prepared data. Now, in fact, we typically take a portion of the carefully trained or prepared data. The portion split typically, not uncommonly, is a 70-30 split. We take 70% and we use that for training the data mining model. When it comes to testing the accuracy of the model, we have a reserved 30%. And essentially it works like this. We can then use the input data to predict what the value we're predicting is, and we can compare it to what we know actually happened. The ratio of how often it gets it right is a very strong indicator of accuracy. Okay, so ensure you have sufficient volumes of cleansed, prepared data that you can split them into the two sets and use them to test the accuracy. And I'll show you this in demonstration. Next, when it comes to querying the model, as a queryable resource, we can query it and we can return additional information. For example, there's my customers and there is the profit that they're likely to generate. And that's the prediction values you can see added to the result set that's returned. So with that background theory, I haven't really talked about SQL Server, and now is the opportunity to do so. SQL Server has, interestingly enough, since Analysis Services 2000, included a data mining component. In 2000, it was pretty primitive, but it does reflect Microsoft's approach to business intelligence, and especially end-to-end business intelligence, in that SQL Server with Analysis Services was the first product to include data mining as a standard feature. Now, it wasn't until the 2005 release that we saw the maturity of the data mining engine and the development experience and the 9 algorithms that we continue to work with today. So essentially, Analysis Services has 2 components, one for data models, whether they're cubes or tabular, and then it also has the data mining. Be aware when you install Analysis Services now in SQL Server 2012, you'll give it a radio option. Which mode of Analysis Services are you installing? The default is the multidimensional and data mining mode. Of course, that's the mode that has the data mining component. The second mode, which is tabular, does not support any data mining capabilities. So SQL Server data mining attempts to hide the complexity of what is an advanced technology. Now, I'm not suggesting you should just disregard all of the statistics knowledge that would better drive a better solution, but you're likely to still be able to produce a reasonable solution with less experience. Okay, I don't know how I can say that better. So I'm not going to suggest that you could just go in here blindly and create a model and use it to predict what your customers are going to do. However, especially as a first opportunity for you to work with data mining, this is an excellent choice of tool. It's very consistent in the way that it works. It uses wizards, it uses the Visual Studio designers, and it works beautifully on top of SQL Server and other commonly used data stores. It includes a full suite of algorithms. In fact, there are 9 of them that allow you to detect patterns in your data. You can work with large volumes of data and complex data. And data can also be sourced from relational and BI semantic models. It's quite uncommon, to be honest, that you would in-source training data from a data model like a cube. It's possible. Typically, you'll want it to come from relational because at the relational level, you have a high degree of manipulation within the relational engine to prepare the data. You can't really do this very well within a cube, for example. Now, of interest to the developer, when we interact and programmatically interact, there are interfaces like XMLA and DMX. XMLA is XML for analysis. This is the XML that defines definition and commands for objects in analysis services like cubes and databases. DMX standing for data mining extensions. So if you've already got a background of working with SQL queries, you're 90% a DMX query writer, because data mining extensions take the SQL basics and they extend it with prediction capabilities. So there are prediction functions, there's the ability to perform a prediction join to bring in a set of new customers to then predict on that set. So you'll see in some demonstrations in this session how this greatly simplifies the integration of data mining results and the embedding of them into applications. In contrast, by the way, if you're working with high-end dedicated platforms for data mining, not only do they have terrible user interfaces or they're command line driven, which means you've really got to know what you're doing. I mean, they're very good platforms, don't get me wrong, but when it comes to integrating their results, there's not a good story. So the fact is you might have the most perfect data mining model that predicts something for you, but you want to integrate this with your ASP.NET application, good luck. There may be no interfaces to even do this. And so then you've left with a dilemma of how do we get that mining model data into a form that can be readily and real-time queried by my application. You do not have that issue here with SQL Server data mining and the .NET libraries on top. So this allows you as a developer, by using this complete framework, to produce a new class of applications that we'll term intelligent applications. So let me introduce you to the 9 algorithms. There's naive Bayes. In fact, this is one of the older statistical techniques. You've probably studied this already. It's probability theory. All right, so naive Bayes is quick, it's easy to work with, it's used for classification. This is where we want to know, is this customer a good customer or a bad customer? We're classifying them into some discrete outcome. Decision trees is a more recent technique. It's a popular technique simply because it's very easy to configure, it's very fast to process, and even those that have no data mining experience, let's just say a business user that wants to learn about the patterns in the model, can readily use the tree to explore and understand the patterns found within the model. So decision trees is interesting because it can work on different types of tasks like classification, regression, and association. Classification, I've given you an example. Do they or do they not do something? Or what color will it be? Regression works with the prediction of a continuous value. How much profit are they likely to generate? Naive Bayes cannot work with this, but decision trees can. And in fact, it's Microsoft's implementation of the decision tree that does regression. The standard decision tree that's available out there doesn't do regression typically. The way that it achieves this, it uses the Microsoft linear regression algorithm. So a fairly straightforward algorithm that finds that straight line between two variables. Where's the best fit? Again, this is something you've likely studied in statistics, even 101 statistics. This is not an algorithm you're likely to use direct, but other algorithms will use it, like the decision tree algorithm for regression will at each node of the tree have a linear regression formula that it uses this algorithm to detect. Moving into the big boys, neural network and logistic regression, they're closely related. As far as I understand, they work with the same patterns and networks that we have within the human brain. These can work with quite sophisticated and complex scenarios. They can work with both classification and regression. However, what you're going to get at the trade-off of a likely more accurate result is a lack of explainability, if that is in fact a word. So whereas naive Bayes and decision trees, you can actually work back and understand from the actual training data how they've arrived at the outcome they have. For these, it's black box. It's like, there's the result. So it's like your bank manager saying, sorry, your loan has not been approved because computer said no. And that's what you're going to get with these algorithms. So it depends. If it's important for you to have that explainability, then you probably wouldn't use these. Clustering looks for natural groups inside data. Now, the human mind can work with this typically up to 2 dimensions, maybe at a struggle up to 3 dimensions. But if you're looking for clusters within multi-dimensional space of data that has strong affinity, then the clustering algorithms can do this. Okay, fraud detection will use clustering quite a lot because what they'll do is produce models that consist of good clusters. If a bank transaction comes in and it has a strong likelihood and association with this cluster, and we know it's a good cluster, it's an okay transaction. If we oversample and we know what our bad transactions look like and it has a strong affinity to a bad cluster, well, it's likely to be a fraudulent transaction. The final 3 then, sequence clustering, time series, and association rules. So sequence clustering is just clustering across a discrete set of sequence steps. For example, like a weblog analysis, that when they go to the home page, 48% of people go to the shopping page and so on. You can then plot an understanding of the usage of a website. Time series is your forecasting. So if you've got a historical series of data, it'll detect a pattern within that series and then it will predict future steps within the series. Out of interest, not much has changed in 2005 or since the SQL Server 2005 release. However, this is one algorithm that was enhanced in the SQL Server 2008 release. Under the covers, there's in fact two algorithms. There's the ARTXP, that's the autoregressive trees with cross prediction, and there's the ARIMA, which is the integrated moving average. The former is better for short-term prediction, but it becomes typically unstable very quickly because it uses predictive values to produce new predictive values. So it becomes wildly inaccurate very quickly. Whereas the ARIMA is looking for longer trends across time. So what the algorithm will do by default is actually blend the two together to give you a more accurate short-term and a more stable and accurate longer term. You can, depending on your edition of SQL Server, play around with the mix there, turn one off or produce something beyond a 50-50 mix. So on that note about versions of SQL Server, as I mentioned, not a lot has changed since 2005, that in fact everything that I demonstrate to you here today could be achieved on 2005 or 2008 or 2008 R2 or 2012. The last one, association rules, this will be my last demonstration in this session, is for your market basket analysis, that those that bought this bought that. So it works with item sets and rules about associations between, for example, products, or another example could be patients, that patients to get this disease are likely to get these diseases as well. All right, so there's the 9 algorithms that you have. Are you confused? Which algorithm would you choose? It's not as daunting as you might at first think. If you classify them into the tasks that they're there to do, for example, it's for classification, there's only these 4: decision trees, logistic regression, naive Bayes neural network. And if you need that explainability, well, you can discount 2 as well. When it comes to estimation or regression or the prediction of a continuous value, you have decision trees, linear regression, logistic regression, neural networks. Clustering and forecasting, no choice whatsoever. And really for association, no choice either. Decision trees, while it can do association analysis, is restricted to 255 items. In a supermarket, that's probably not going to cut it when you think about the extensive range of products that they have on their shelves. All right, so association rules is really the dedicated algorithm for market basket analysis. Now, it's all very well to process a data mining model and to have it contain patterns. But how do we convey the meaning of those patterns back to the human, the consumer, be it a marketing manager or so on? So in contrast to OLTP and analytic queries against a data model, data mining queries typically extract information the user's not aware of. So what's spooky about it is that you typically know the question you have when you go to a cube. What were the sales last year in Brisbane? For data mining, it might be, here's the answer to a question you didn't even know to ask. It will surface to you patterns that it's discovered, and that's part of the magic. Well, it's not technically magic, but it feels magic at times. Users do not typically query data mining models directly. Instead, they might get to them via reports or application experiences or through visualizations. And in fact, SQL Server data mining includes 12 visualizations. I'll show you how you can embed them into applications in a moment. And these visualizations provide interactive exploration and discovery of what those patterns mean. The visualizations can be used to test and explore models in both the development environment, also Management Studio. If you connect to analysis services, right-click a model, browse, those visualizations are available for you in the management environment. But you can also embed them into your own Windows applications and distribute them royalties-free. Of course, they do need to connect to an instance of analysis services, so that's where the licensing comes in. The application is only as good as the connection to a mining model and the permissions that that user has to connect and query the model content. There's a good plug-and-play architecture with data mining, so if you're not happy with the 9 algorithms, I'm not suggesting it's a trivial task, you can develop your own algorithms and plug them in and extend the data mining engine. And likewise, the visualizations that are available, you can build your own and plug them in. It's a non-trivial task. It's pretty advanced stuff. When it comes to programming and connecting to and querying the mining models, you can see there at the very, very top, we have different libraries that would be used by UI developers. We'll focus here on the .NET applications. We have ADO.NET, ActiveX Data Objects. So if you're familiar with how programmatically you connect and execute a command against a connection, it's precisely the same. We connect to analysis services, we bring up a DMX query, and we execute it, and we bring back a result set, and you do something with the result. It could be as simple in a .NET application as binding it to a data grid. and there is the new customers and the likely profit that they're going to generate. So for those that are already familiar with building applications that query and consume relational data, there's not a lot that you need to learn to adapt this to a data mining solution. There is all the theory. What that means for the remainder of this session is I have a series of 5 demonstrations that build upon this theory to show you how you could use data mining in some application experiences. Are there any questions before I move into the demonstrations? Okay. Oh, there's one over here. Yes.
You mentioned the parameters for some of the different
Algorithms?
algorithms. Is one of those for the neural networks, like how many nodes it uses, how many layers?
Right, yes, so each algorithm, the question is about the algorithm parameters, and I'll point them out during demo. Each algorithm has specific parameters that allow you to constrain or optimize according to the results you're wanting or the data that you have available to it. So I'll do a couple of tweaks in one of the demos later. My favorite database, at least from an instructional point of view, is AdventureWorks. I know that some of you may be completely tired of it, but I've got to say it makes my life easy when it comes to conveying basic concepts that I already have a data warehouse for a fictitious bicycle manufacturing company, and I'm going to solve some problems for AdventureWorks today by identifying customers that are likely to buy bicycles, by helping them convey information about new customers and the likelihood that they will buy from us, so that we can better direct our efforts towards customers that have got that potential to buy. Also, help with the user data entry, that we could validate data by using data mining. And finally, the classic, those that bought this with that at AdventureWorks, they have an e-commerce application. We want to enhance it so that according to the content of the market shopping basket, we will then provide suggestions about what else they might want to purchase. So I'll introduce you to my projects here in Visual Studio. If I just go ahead and run this, I've got this very, very simple C# Windows application that when I run it, it goes ahead and gives me this very basic starting point to choose different options, or it should do. There are build errors? Okay, only when you're demoing. I think what happens is if I close this and reopen it, it fixes the problem, oddly enough. You sacrifice the demo gods. Yes, good point. Insufficient sacrifice to the demo gods. Let me try this again. There we go. Right, so this is not data mining so far, but this is just a basic application that's going to allow me to view a data mining model, view a report, and handle a data entry system. I have no data mining developed at this stage. I have a reporting solution that we'll come to in a minute, but I right-click my solution, add, new project, and then here in the templates for analysis services, I select the analysis services multidimensional and data mining template, and I'll name this the sales mining project. So for those that have developed cubes, this is not anything different. We start by defining where our data comes from. So the data source that I'm defining here represents the data source where that carefully prepared data resides. Just so happens that that is the AdventureWorks data warehouse. And it will use the service account's credentials to connect to it. That's usually not a best practice. We would typically have dedicated domain accounts used to connect, but for simplicity in this demo, that's what I will do. So there in my project, I have an item that defines a connection to the data warehouse. The next step is to then define a data source view. So this is a virtual schema upon which, by using a data source, I can introduce the tables of interest. In this case, it's the target mail. I'll provide a name for it. And in the target mail table of this data source view, I go ahead and explore the data. And what I point out to you here is that for all of the AdventureWorks customers, we have very rich and accurately maintained demographics. So take a look at some of these columns, like what is your gender, what is your age? Note the continual values here for age. Marital status, do you own a home, yes or no? Number of children, what is your education level, occupation? Look at the prepared discretization here for income into 20,000 buckets. Commute distance is also discretized. What sales territory group do you come from? All of those, with the exception of the very last column, come from our customer details table. The very last column has joined the individual customer to sales history, and it's returned a Boolean value. They either have or have not purchased a bicycle from us before. So with this information, what we're going to be looking for are patterns between the different states of yes and no for being a bike buyer to see if we can detect anything interesting. So then I move on to the mining structures, and I define a new mining structure, all wizard-driven. That's what makes this very, very approachable. The data is coming from a relational source. As I recommended, that is usually the best source. Here are the 9 algorithms, which it defaults to the most popular, being the decision trees. Next, which data source view. And next, which table within the data source view contains the cases. The cases represent what we're interested in this case, the customers. There's only one table, so I don't have much of a choice. And then it says to me here, okay, well, what columns will define the structure and the very first model within the structure? So be aware of this. In data mining with SQL Server, you have this concept of a structure that consists of the definition and the actual data, and it can split the data into training versus testing sets. You can then have within this structure multiple mining models that leverage the same structure and data. So what we're doing in this step of the wizard, on the left-hand side are the columns that would be included in the structure, and on the right-hand side are the columns that would define the very first model within the structure. So you'll see that the only selected option there is that the customer key has been identified as the unique identifier. This represents the unique identifier for each case within the table. I know that what I'm looking to do is predict the bike buyer column. Yes or no, are they a bike buyer? And so I select it. And note the way it gets selected here on the left-hand side. It has to be in the structure if it's in the model. Now, when it comes to the inputs, you can work through the list and say, well, age would probably impact on the bike buying decision, commute distance, or you could take advantage of this button down here. By clicking suggest, it actually uses data mining techniques under the covers, not SQL Server data mining, by the way, and in descending order of relevance, it actually does a check with your data, or at least a sample of it. And it says, does it find any correlation between the yes-no states? And in descending order, then, you can come in here and say, yep, they're the ones that should be my inputs. Now, it strongly suggests that if you're working on a project like this, you really should know this anyway. You've been carefully preparing the data, so you probably shouldn't be fully reliant on this type of assistance. Clearly, a column like, let's use phone number. You wouldn't expect phone number would have a direct relationship to the yes-no output of a bike buyer. But it could be useful to include it in the structure all the same. So you'll note here that I'll include it, but it doesn't form part of the model's definition. Clicking next, for the columns that were selected, you need to define the content types and data types. Let me start with data type because the data types are fairly straightforward for data mining. And there's a direct relationship between SQL Server data types and the data mining data types. So you shouldn't need to do anything here. It's either numeric or it's text or whatever. Now the content type, I mean, its rule would be this. If it's text, of course, it's got to be discrete. If it's numeric, it could be discrete or continuous. And you're likely to have many distinct numeric values. It's likely to be continuous. So in fact, when you go ahead and click detect, it does run some queries column by column looking for the distinct values found in the numeric columns, and you can see here it's updated everything with the exception of age to discrete. We can override this, which will be the case here. I'm going to say that it's discretized, that you can actually control at that attribute level that you should discretize it into 10 groups, and you can use different statistical techniques to determine how many belong in each group. While you can do that with analysis services, you're far better doing this in your data preparation phase to get exactly what you want. You can do it at this point. I will do it because it lets my demo continue, as I'll describe in a minute. So I'm going to configure discretization for the age. Clicking next, what portion of the structured data should be reserved for the testing of the models? Actually, this was new in 2008, so you won't have this in 2005. And it's simply that the structure will permanently store test versus training data sets. 30% is a pretty standard value, so I'll leave that at 30%. Click Next. We've arrived at the end of the wizard. Two names have to be given, the name of the structure and the name of the first model. So the name of the model will be called target male DT for decision tree. I'm also going to turn on the drill through and I'll demonstrate what that allows you to do. Click Finish. And what you'll see is the addition of the target male structure. Here is the structure itself. On the second tab, we get to see there is one model against the structure. And I can come in here and say, but let's add a new mining model. So now we have two. And the name of this will be target male NB for naive Bayes. And that is why I discretized age. Naive Bayes doesn't support continuous values. So the discretization of it will allow me to use naive Bayes. Two models, one structure. At this point, I right-click the project and deploy it. What that will do is script up the entire project, send it to my analysis services instance. That's the multidimensional and data mining mode of analysis services. And then the default processing option says process anything that needs to be processed. The entire structure would be processed using the 70% of the data available through the vTarget Male view. That would then allow me to switch across to the third tab, which is to visualize. Now, these are the visualizations that ship with the product. You can toggle between the models that you have. Let's start by exploring the decision tree. So there are two visualizations here. This is the decision tree itself. And what I'm going to visualize are the bike buyers that would buy from us. What that means is that as I explore the tree, the darker shading attributed to a node will represent that there are more bike buyers in that node. So you can see here visually that the attribute that was most influential in determining whether you do or do not buy a bike is the number of cars that you owned. That if you don't own any cars, and take a look at the mining legend here in the bottom right corner, there's a 62.36% chance that you would buy a bike. And then you can continue to explore, and this really emphasizes the simplicity of conveying what this model has to tell us. That if you don't own a car and you're less than 45, then it's 75% chance. And that's significant because it's 999 cases there. That's happened 999 times. And you can continue to explore so long as there's additional nodes. So if you don't come from North America and you're less than 45, you don't own a car and you don't have two children, it's pretty much 94%, according to 491 customers. Now, the drill through that I turned on would allow you to right-click here and drill through to the model columns only or the model and structure columns. So if I choose the latter, I also have information like what phone number. While phone number was not relevant for the mining itself, I can include it there to allow loopback to my system to verify the results. There's the explainability coming back to us. There's a second visualization for decision trees, and that is the dependency network. So you can see here that we're looking to predict the bike buyer, and if I slide down, you'll see education drops off first. In fact, education is the weakest. Very little impact on whether you buy or don't buy a bike. If you scroll right down, you'll see the top three come to age, sales territory group, and number of cars owned, with number of cars owned being the most influential attribute. So there's meaning that can be easily conveyed back to a non-data mining expert. Let's take a look at the second model, which is naive Bayes. So interestingly enough, it also uses the dependency network. Fewer attributes on here, in fact, education's there, but marital status, it determined was the least influential, with its top three being commute distance, total children, and number of cars owned. Sales territory group was in the top three for decision trees, but not for naive Bayes. Which one is right, which one is wrong? I'll use this opportunity to reinforce that SQL Server, or rather data mining, is not an exact science. Different statistical approaches arrive at different outcomes. So which one is better, which one is more accurate? We will answer that question in a moment. There are actually three other visualizations for naive Bayes. This one I won't focus on. I don't think it's really useful for what I'm trying to say. This one here, show me for the yes bike buyers in descending order of states what the highest to lowest probabilities are. So you can learn about your customers that do buy bikes. We'll find that, predominantly, or at least 62% of them, don't have children at home. Whether married or single, it looks like a 50-50 split, so that has no impact. And North America, and they live close to home and so on. And in fact, with the attribute discrimination, you compare two states side by side. What about those that do versus those that don't? And see the very two top ones there telling you the number of cars owned. If it's 0, they're likely to buy a bike. If it's 2, they're not likely to buy a bike. Therefore, when educating your sales force, this would be a classic thing to have them learn, that when they're on the showroom floor, the types of questions you're going to probe are, how many cars do you own? Because clearly that's the discriminator against you do or you don't buy from us. The question is, though, we have two models, and only one is going to make the cut to be deployed into production. So here on the 4th tab, we have the mining accuracy chart, and I can come in here and say, well, let's predict for yes and use the mining structure test cases. That's the 30% of the data. And now when I switch across to the lift chart, you get to see that there are actually 4 models being plotted here. Look on the vertical axis, what we have there is the target population versus the overall population. So the way to interpret this is, let's start with the random guess model. Of course, this isn't one of our models, but the random guess is telling you here that in order to find all of the bike buyers, you must sample 100% of the data. That's not efficient. That's like sending that expensive brochure to everybody. The other end of the extreme would be the ideal model. Now, this is perfection. It's telling me that you could sample 50% and stop, and you will have found all the bike buyers. This is not data mining. This is the perfect world. What it's telling us is that if you go to the 30% of that prepared data and you did a count of those that are yes versus those that are no, you'll find there's 50-50 in there. It's the actual result according to our test data. What we're interested in then is our models that fall in between random and ideal. So in fact, we discover that the decision tree model is closer to ideal than the naive Bayes model. So you can use this point here, for example, that if we sample 50% of our data, we will find 71% of bike buyers. Now that's an improvement upon random, isn't it? Where we would have randomly picked them and found 50% at the 50% mark. So this is called a lift chart, and the reason it's called a lift chart is that the lift from random, essentially that 21.26%, is the value that data mining is delivering to you here to help you detect those customers that are likely to buy. So from this interpretation, we'll make the decision that the decision tree model is what we'll use moving into production. So the last tab within the mining structure designer allows you to select a model, like my decision tree, and select a case table. In this case, from the AdventureWorks data warehouse, I have a view that represents the new customers that have joined us in the last 24 hours. This is what we call a prediction join. You have the model and you have this set of data that is joining. The joins are established automatically if they have the same names and equivalent data types. And then I can build up a query graphically simply by double-clicking first name, last name, and I'll bring in phone number and the sales territory group they come from. Now this isn't data mining at this point, I'm just querying columns, but there's the ability to add a prediction function. The prediction function that would work for this model would be predict probability. I'll alias this column as confidence, and I'm predicting the bike buyer, comma, yes. Predict the probability that they will produce a yes. And then if I switch this across to results, look in the status row there. Almost instantaneously, 297 customers now have attached to them a probability that they will buy. And now we're in a position to perhaps order this in descending order of confidence and start promoting to those that are most likely to want to buy from us. Sorry, the question is?
Why not concentrate on the other 30% to get them to buy?
Well, okay, interesting point. The question is, why not concentrate on the people at the lower end, because maybe they need to be convinced that they need a bike. You could take that approach if history tells you that that's worthwhile. But what you have to appreciate, that this is a flawed assessment when you think about it. If they've bought a bike from us, or if they haven't bought a bike from us, doesn't mean that they would never buy one. It might mean they already had one, they came to us and bought accessories. So you have to be very, very careful in the way that you interpret the data that you have. You can't simply say that because they didn't buy a bike from AdventureWorks that they never would, but you can only do with what you've got. And that's what you need to understand when you're producing these types of solutions. As you can now appreciate, the lift that we see there is delivering some value. Is it worth the effort? Might be a question to get that value. Okay, so that's first demo, end-to-end producing a data mining solution. I'm going to move then into the next topic about embedding those visualizations. So we saw them here on the third tab, was that there are these rich visualizations. How can I use these visualizations and distribute them within the organization? So in my little demo application, I have the DM viewer form. Pretty much empty at this stage. When I go to the toolbox, I can go ahead and you'll see here that there are data mining viewers. Now, these data mining viewers are only here because I added a DLL to the toolbox, and that DLL will be found once you've installed SQL Server. And like I've mentioned, you're able to distribute your applications that use these viewers, providing that those applications and the users of applications have a license to connect to SQL Server. So I just drag the tree viewer in, and then I configure its properties. So it's reasonably straightforward to do this. Let me go ahead and dock and fill the form with that visualization. I then need to configure the connection string that it would use. So the approach that I use here is to create a UDL file. So just by creating a text document like sales mining and changing the extension to UDL, a universal data link. Now when I double click this, I get this interface that allows me to select a provider and then configure the connection. Now if I open up this UDL by using a text editor, there's the connection string that I want. Now in the real world, I would not suggest that you hard code this into the property of the control. This should be in a config file, obviously, so it could be changed as necessary. The other thing that it needs, now that it knows the server to connect to and the instance, is which model. So the mining model name will be target mail DT. And the last thing I need to do by double-clicking the form title is in the load event. So when the form is loaded, I go to the control, and there's a method called load viewer data. Don't ask me why I have to pass in null. There's no documentation on this, but if you pass in null, it works. And now when I run the application and open up the DM viewer, granted that the user has permission to connect and query that model, there's the entire visualization for them. There's the mining legend, they can switch between the dependency network. So sharing data mining results could be as simple as that. It only works for Windows applications. There's no ASP.NET equivalence, but there's nothing to stop you querying the model and visualizing that by using your own skills.
Is that available for WPF?
Is that available for WPF? No. All right, that was my second demonstration. The next one is involving practically no code, right? The next one will be to show how reporting services can also work with data mining. So I have a partially built report here called telemarketing call list. Essentially what we'd like to do is parameterize by the sales territory group. Are you North America? Are you Pacific? Are you Europe? And then I'd like to retrieve the new customers that have joined in the past 24 hours in descending order of the probability that they would buy from us. And then this could be used by those pesky telemarketers to go ahead and then ring from the top down, assuming that the top ones are a better chance than the lower ones. So in this report, there's already a data source that connects to the data warehouse. That's for the benefit of retrieving the sales territory groups to give us a drop-down list to choose which sales territory group to report against. What I'm going to do is add a shared data source to the project that will use the analysis services provider, and I'll connect to that sales mining database. So from a reporting services point of view, it's just a DMX query that's being executed, and then you have a data set consisting of the fields of that DMX query. So here in the report, I can add that data source, and when I right-click the data source and add a data set, because it's the analysis services provider, it doesn't allow you to type in a query. In fact, that box is disabled. It really wants you to click here and open up the query designer, and because it detects that in this database there are no cubes, it switches automatically into the DMX mode. So it's prompting us to choose a model within the database. And so we'll choose the DT, target mail, bring in those new customers from the AdventureWorks data warehouse, and then build up our query. So it's exactly the same query designer, but embedded into reporting services. First name, last name, phone number, sales territory group, but don't output it. There is parameterization support here. Sales territory group. And I can also set what the default value for that parameter will be. Europe. And then the data mining comes in, a prediction function that will predict the probability, aliased as confidence, that that customer is a bike buyer. There is the resulting DMX. Okay, so very much like a select statement from the T-SQL world. So there's from, it's always from a single model. The select clause brings in your columns and can introduce calculated columns by using prediction functions like this. What is unique to DMX is a prediction join. So it brings in, by using an open query function based on this data source, the result of this query, and it aliases this as T. And then it joins on the model to the prediction join result. So the rest is standard reporting services. I'm going to go ahead, add a calculated field like customer, and build up that we need the fields that is first name, concatenate to a space, concatenate to last name. And then I can configure this table using the sales mining connection and the DS main dataset, put the customer in the first column, put the telephone in the second, and the confidence in the third. I would then come to the group here and configure sorting to sort by confidence descending. So then to preview this, it will default to Europe, but we'll have a report parameter at the top, and here is the data mining query being executed by the report server and the results being rendered back in this HTML report. So an effective way to convey data mining results, and one that's very, very straightforward if you know how to build a report like this, is that you can embed reports into applications. So perhaps your effort is just have a query through a data set, bring back the data mining result, publish the report to the report server, and then embed a report viewer control into your application. So what I'll do here is right-click my project and deploy it, so that report is now on the server. And so you'll see here that there is the server it was deployed to. Let me copy that. And then in my little C# application, I have a reporting form. So in this reporting form, I'll come to my toolbox and I'll add in the report viewer control. I'll configure it to work on a server report, and I'll paste in the URL to the report server. The next thing is the path to the report itself is down here. In a folder called Data Mining Reports, there's the telemarketing call list. Let's see if I can copy that. Data mining. Telemarketing call. And then dock that in the container. No code. Run. Open up the DM reporting, and something isn't configured properly. You tell me now.
I thought you knew what you were doing.
I usually do. So what have I done? I guess I still don't see it.
Backslash instead of forward slash. After reports. Forward slash D. Forward slash.
Yeah,
That's backslash. That's all.
thank you. I should normally be able to copy and paste that, but for some reason in 2012 it doesn't let me. All right, let's see. And we have success, thank you. All right, so no code whatsoever, and the ability to distribute data mining results. Now, think beyond the application experience as well, because SQL Server Reporting Services has subscriptions. And a data-driven subscription here could automatically send this report out every 24 hours to the different sales territories and say, well, there's the new customers, and there they are in descending order of confidence that they'll buy from us. Question?
With that query language that it got generated, is there any way to actually use that from ASP.NET just to get the raw results?
Absolutely. So the question is, could we not just bring that result in, that DMX statement, and execute it through ADO.NET? Absolutely. It would just bring back a result set no different to what a SQL Server relational result set would look like. In fact, we'll go there in an upcoming demonstration. So that was demonstration number 3, 2 to go. The next one is the dilemma of how do we validate data entry data, especially when there's complex relationships between the different attributes that are being entered. Let me show you this with a little demo application that I have. I've kept it very simple for demonstration purposes, but the fact that I would choose someone that's high school, earns less than 20,000 and then says that they're in management, while you could enter that and submit it to the database, it would be very hard to write fixed logic that would say, oh, that's probably not right. Yet what we could do is we could use a data mining model to understand the relationships between the different states of income, occupation, and so on, and know what is likely to happen. Now, this is a task for a clustering model. It can build clusters around what the data looks like. And therefore, at data entry time, when we submit, it can fire off a query that says, what is the case likelihood that it belongs to a cluster in this model? And if that case likelihood comes back as low, you could go back to the user and say, unlikely that that should happen. And even better, we could just adjust it to say, and we think this is what is wrong, go and address this. Now, of course, you don't want to constrain a user that, this could be that 9-year-old PhD student. It does happen sometimes. But what you could do is then say under the covers that if it doesn't fit very well, at least flag silently that row, and someone can come back and audit it later on. Don't stop the data entry process from happening or forcing them to put whatever values work in, because then you'll end up with even a worse situation. So this is how I'm going to solve the problem. Back in the target mail, I'm going to introduce a third mining model. This will be target mail, CL for clustering. It just inherits the same assignments of key, input, and so on, but I'm going to change that. In fact, for everything except the key, I'm going to change them to ignore. There's a bit of a trick here. If you multi-select and press F2 and then update, it will update all of them. So for each customer, what I want to do is predict just 3. That will be education, that will be occupation, and that will be income. So fairly simple model, and I'll deploy this, which will result in the creation of the new model and the processing of it. Now I can switch across to the mining model viewer, and we can take a look at that new clustering model and see that by default, in fact, it's an algorithm parameter that says, how many clusters do you want? It's set to 10. So here are 10. You can see there's relationships between them. Time doesn't really permit, so I'm going to show you this visualization here. What's important with clustering is to understand why a cluster is different from the rest. That can be challenging, actually. So let's look at the very first one. Cluster 1 here. If I select the education variable, you'll see here in the histogram that it's predominantly people with bachelor's and graduate degree. Let me choose something a little different. What's cluster 9 look like? Predominantly high school people here. Cluster 9 represents people that are 95% high school. Their income is either less than 20,000 or between 20 and 40,000, and then their occupation is typically manual, maybe skilled manual. I could come in here and right-click this cluster and say, this is manual workers. This is the hard part about clustering, by the way, is coming up with an appropriate label that defines why that cluster is different from everything else. And you would do that for all of the clusters to understand what it's discovered. In the mining model prediction then, what I'm going to do is build up by using the clustering model. I'm going to use what's called a singleton query. Instead of using an external set of data like my new customers, a singleton query represents one case, and we get to input what the values would be. So let's go for that case of someone that is high school educated, is earning less than 20,000 and is a manually occupied person. And then what I could do is run a prediction function and say, well, go and predict the cluster, and you'll see it actually comes back with that cluster named manual workers. That was the rename that I gave it. So it's found the cluster that best describes that singleton case. What happens if I change this to graduate degree? It's actually cluster 7 is a better fit for it. So putting that back, I will then introduce a second prediction function, this time to predict the case likelihood. And when I run this, it's telling me that for the manual workers cluster, it's an 87.88% chance that it fits. Strong affinity. Okay. Another prediction function. Let's predict the probability of education. Predict. Let me just use predict. Now what the predict function is supposed to be doing.
Can I find out something?
Yes, you can. What am I doing wrong?
You set 2 of your inputs to inputs, not predict.
Thank you. They're supposed to all be predict. Good pickup. Reprocess. Requery. Result. You don't want to give me the result. I might have to retype that in. Singleton query. Prediction function. Predict the case likelihood. Predict education. Predict probability. So that's why predict probability was not working, because it was not a predictable attribute. So what I can say for that manual worker earns less than 20,000, high school educated, is that for the cluster we identified as my manual workers cluster, there's an 87.88% chance they would belong, and education comes up with 40.65%. So it's interesting to look at this because what we can learn for that cluster, it was 9, wasn't it? No, if you reprocess it, you lose the cluster names. You have to redo them. Well, it's because it might come up with completely different clusters depending on what you're configuring. A different algorithm parameter could produce a different number of clusters or different assignments. Basically, this distribution here is what it's finding. It's telling me for the cluster that it belongs to that the education is 40%. The question is, what education is it? When we just ask for education, it's giving us the highest probability for the cluster that it found. Let's just see what cluster it was. So it's telling me it's cluster 9, 40.65%. Come to cluster 9 for education. It's that one there. No, it's not. Education, it should come up with 95.8%. Cluster 9, education. The highest probability should be 95%. What's it doing? Okay, I'm not sure why that's doing that. It's not supposed to. Anyway, someone said you can always pretend. Yeah, look, it normally works. I'm guessing maybe it's a little confused. I don't understand why, but I don't have time to fix it, but this is how it's going to go. What I'm going to point out to you is that prediction join is using a singleton query here, which is basically a select statement of constants. It's aliasing this as t. I'm going to copy this, and I'm going to switch across to Management Studio, and I'm going to fire up a DMX statement. This is how to work in the application. If the cluster case likelihood is too low, and 45% is my threshold, something's wrong if it can't be 45% close enough to a cluster. Go and find the ratio of the education, for example, the probability of education over the highest probability of education. If you can do that for each of education, income, and occupation, the lower ratio of the 3 will tell you where it's probably not the right value. Let me put this together in a query. So what I'm going to say here is, if I predict the probability of education, that will give me the highest probability if I put on the numerator to predict the probability of t.education, so t represents the singleton query down here, so whatever the education value is, which is high school, give me the probability of high school over the probability of the highest probability within the attribute. So now if I go ahead and run this, we can see here that it's a 49% fit. So what I'm going to do is copy this to also do income and occupation. Income. So now running this query, I get 4 columns coming back. The case likelihood that it's a fit, we can see here that occupation is the perfect fit. The lower of them is actually income. So we'd actually suggest that if this threshold wasn't met, and it has been, 87% is pretty good, then it's this one that we're in doubt about. So if I can take this query, switch across to my .NET application, and I have my data entry here, view code. There's the threshold, 45%. There's the connection string connecting to my analysis services database, and it's here that I'm going to have the DMX executed. All right, instead of putting high school in there, I'm just going to build up, take whatever's in the CBO education.text. Of course, watch for injection attacks here. CBO income.text, and manual becomes occupation. So now when running this application, that is the query that will be dynamically constructed. Data entry here, let's go ahead and put in there that high school educated, income less than 20,000, manual, submit, 87.87% chance, there's the DMX. What if I then said that they were earning greater than 140,000? 0.03% chance that would happen, and income is the most suspect one. There's an example of clustering, how we could use it to support validation of data. Okay, it would be very difficult to hard code what the rules should be based on the different values that they could choose. Last example is the association rules. So for this one, I'm going to switch across to an ASP.NET application, represents the AdventureWorks online shopping experience. And so for the moment, we can see that we'd authenticate, we'd come in, we would select a product, add it to the shopping cart, and oddly enough, it suggests that we might want to buy these 3 things, of which Mountain 200 is already in the shopping cart. And the reason for this is that it's just running a store procedure that returns static suggestions. The demonstration goes like this. And I'm running a little over time. I think I need 5 minutes if that's okay by you. So I add a new data source view. And this will bring in a couple of views that give me my orders and the order lines. There's a one-to-many relationship. An order can have multiple lines. Basket analysis. I provide more friendly names. This becomes order. And this becomes the basket. And there's a relationship between the two. And now I can build a mining structure based on top of this. So this time using association rules, the basket analysis, data source view, my order is the case, the order is the case, and the basket is nested within it. I configure that it's the model that we're looking to predict. I don't need to change content types or data types. I don't need to reserve any data for testing of accuracy because this algorithm just gives me statistical fact. Basket analysis becomes the structure, and the model is the AR model. I will tweak the algorithm parameter here because I don't have a lot of sample data. I right-click, come to the algorithm parameters, and for this algorithm, I'm going to change the minimum probability of minimum support, just to make it a bit more sensitive because I don't have a lot of data. And then I deploy. And basically this algorithm will get frequent item sets. How often do things get purchased together? From all of the frequent item sets, it's able to determine rules about how things happen. What happens when we buy something versus something else? And the visualization is all here. The item sets show me in descending order. here are the things that happen at least twice. We can see that 1,623 times Mountain Bottle Cage and Water Bottle were purchased. The dependency network, and let's take a look at the Mountain 200. We can see here that Mountain 200 will predict these other things. And as we slide down, you'll see that Patch Kit becomes blue. Mountain 200 will predict the Patch Kit, but Patch Kit at this point does not predict Mountain 200. And this is how a store manager can learn about what's purchased at the same time. This determines product placement within stores. It helps us then in our application to come back over here and modify the shopping cart checkout. So what it's doing at the moment is using a method called get static suggestions. I tell it to use get data mining suggestions. And this method here is doing this. It runs a store procedure that retrieves the content of the shopping basket, and it builds up a singleton query just by unioning everything that's in the shopping basket. It's then able to pass that in to this DMX statement. Select everything in the basket, give me the next three things, and do a natural prediction join to my singleton set of product items. So when I run this, and this time I go to the shopping cart page, you'll see that it's now recommending these three items based on this DMX statement. Just one item, it's the Mountain 200. What if I go ahead and choose the bottle cage, and I go ahead and I'm so impressed, I buy 10 of them, and now what you see is an updated DMX statement that includes both of those items. Go and predict the next three things from the basket that you could then recommend. And that's the secrets of Amazon and how they achieve what they do. And this is something I think is reasonably approachable for you if you have sales systems. They're typically cleansed, high-integrity systems, one-to-many relationship between items purchased at the same time or by the same customer. And you can perform this type of analysis and use this as a recommendation engine. There are the 5 demonstrations that I hope inspire you to the potential of what you can do with data mining in SQL Server. A message for you guys as developers is you can take your application to the next level by embedding the results, including predictions, into applications. Embed custom visualizations, as I demonstrated, and integrate predictions in the form of advertising, those that bought this, bought that, or as you saw, even update the validation routines to use data mining to help detect problems early. Okay, there isn't a lot of related content at this event. A recommended book, however, is SQL Server 2008 Data Mining. In fact, if you go to Amazon and just type in SQL Server Data Mining, this would be the #1 book. This is an excellent book that's targeted at beginners that will take you through the fundamentals of data mining, introduce you to SQL Server data mining, dedicate a chapter to the major algorithms, and also chapters on integration and embedding of data mining. It's a fantastic publication that includes sample data sets and activities also. Have you seen this mouse? Would you like to be the envy of all your friends? And that is, this mouse is available to you, possibly, if you submit an evaluation. It's very important to us that we get evaluations back from you guys about how well we perform, how well we deliver to your needs at this event. Please take the time to go to My TechEd and submit an evaluation for this session. We've run out of time. I'm very happy to take questions offline out here on the front. And I'll otherwise thank you for your time and attendance today. Thank you.